Kinko, for being here. I really appreciate it. Especially, I know you're tired, probably after yesterday's party, no? Tired from party?
Yeah.
You were there. Okay, so my name is Elena. Maybe some of you already know me. I was here 2 years ago. I was here also in Bulgaria last year on another conference. Someone was on the Redis for your postdoc? Okay. If you remember, I made a promise to you at the end of the talk that next time I get invited in Bulgaria, I was going to try and speed up, optimize what we did last time. So today, that's what we're going to do. We can divide the talk into topics. First, we're trying to see how much faster can we get our stuff to run, and then I'm just going to tell you some things that are not that widely known about Redis. How much faster does it get? Very fast. What did we build last time I spoke about Redis in Bulgaria? So imagine we are a startup, and we want to analyze tweets. Okay, so we are a company, and we offer other companies a way to optimize, let's say, user emotion in their tweets. So we can just observe tweets for a certain hashtag, and then try and find certain keywords in them, like love, like, hate, terrible, and we analyze the tweets for those keywords. Our dashboard, to visualize it a little bit, would look something like this. First, we're going to show the number of total tweets that were posted with that certain hashtag, a mainstream of all the tweets, substream of observed keywords, total count of those appearances, and in the end, a leaderboard, a dashboard of the most frequent keywords that are appearing in tweets with our hashtag. The steps that we are going to have to take, the process will consist mostly of this part. First, we are going to send the tweet to the mainstream. Can all of you in the back see, by the way? Is it well readable? Cool? Okay, thank you. We are sending the tweet to the mainstream. We are increasing the counter of total tweets. We're analyzing for the keywords, sending them to the appropriate substream, and in the end, we're increasing the counters. And the steps we need to take in order to do this are the following. This is more in terms of client-server communication. Before we dive into that, let's just see what is client-server communication in Redis. Redis is a TCP server using client-server, the client-server model, and they are connected between themselves with a networking link. How does that communication go? The client opens up a connection to the server, it's a socket connection, and sends packages, requests to the server. That connection stays open, because Redis is a single-threaded server. That connection stays open until the server is thinking which data am I going to send back to the client. When the server is finally ready, it sends back the response to the client, and the request cycle is over. This cycle takes some time, obviously. That time is called the round-trip time. It takes for the packages to go from the client to the server, back to the client. And obviously, you can tell that if the client and the server are on the same server or the same data center, that round-trip time is not going to be that big. Where they're on the same loopback interface, it's about 0.005 milliseconds, something like that. So you could serve many requests in 1 second. But if they're separate servers, for example, if you have in your web app, you have multiple servers for multiple web servers, they need to have a separate Redis instance so they can all communicate to the same data, no? If that's a separate server, even more, in a separate data center, the round-trip time for packages to go from the client to the server and back again is increasing. And my point here is that we need to think about not just how to optimize how we access our data. We need to optimize how we are managing our connections and how much data can we get out of one single network request. So let's go back to our steps now. In terms of commands we're sending from the client to the server, in order to process one tweet, this is what we have to do. First, by the way, I'm assuming that you know basic Redis commands. Am I more or less right doing them? How many of you have used Redis before? Good. Okay, I think we're good then. So we are sending a set request to the server to save the complete tweet. I'm not going to go into details, as actually this was part of the last talk where we were exploring data structures. Let's just think in terms of command and optimization here. So we are saving the tweet. It's a set request to the server. One network request. Add the tweet to the main feed. L-push. 2 network requests. Plus L-trim if we want to trim the list so it doesn't completely fill up our memory. We want to trim limit the number of tweets we want to show in the tweet. That's 1 more network request. Increase the counter for total tweets. 4. Get all monitored keywords. 5. Check tweet for any keywords. This is logic executed only on the client side, so no network request here. And then for every found keyword, we are going to do this. Increase counter. Add the tweet to the subfeed. 7. Plus trim the feed again, so it doesn't fill up our memory, already up to 8 network requests. And in the end, we are going to update the score, that increment by, we are up to 9 network requests just to process one tweet. If we find another keyword in the same tweet we want to analyze, we need to repeat these 3 steps, that's 4 commands. So we will go up to 13. If we find more, 17 network requests. Obviously, that's not really, if we are doing this just for us, we're one company, we build some side service to monitor stuff for us, that's okay, it's really not a big problem. But if we are a company specializing in that, this is really not going to scale very well. And it's not going to be fast enough. We want to provide, in this case, our startup is hip and wants to provide data in real time. What are we going to do? Is there a better way to do this? Pipeline. It's a known technique, it's nothing new, and Redis has it almost since the beginning. This is an example using PHP, I'm a PHP developer. Using PHP and the pRedis library client for Redis. So what we're doing here, what is a pipeline? When we're using pipelines, we're opening a connection from the client to the server, no, from your side, from client to the server, and we're sending the request to the server without waiting for the response, We keep sending requests without waiting for the response, for a response from the server first. The server on its side receives the requests, queues the results, and then when everything's done, sends everything in one batch. So you can already see how much we can speed things up like this. So what are we doing here? First, we are grabbing the keyword we want to analyze from the server. That's one network request. Then we're opening the pipeline, and we're running. And we're running all the commands inside of the pipeline. So everything you see here is going to Redis in one single connection. So why is this call here separate? Now we're up to 2 calls already, only. But why is this one separate? because we need to have the keywords before we open the pipeline. Because if we do it here, we won't have the keywords here, okay? Because the response didn't come back from the server just yet. That's why we're issuing a separate network request here, grabbing the keyword and then the pipeline. 2 network requests. So we're down from 9, or okay, at least minimum 5. If we find some keyword, at least 1 keyword, 9 network requests, probably, possibly more. We're down to only 2 network requests. I think we're doing pretty good, but we can do better. Lua scripting. 1 second, sorry. Anyone familiar with it? Hello, my people. Lua scripting. Redis gives the possibility, the option to run logic inside of the server itself. So we can execute Lua scripts inside of Redis itself. How does that look? First, a real hello, a simple hello world example, no? We create a hello.lua file. In it, we just put in this return hello, nothing else. And then from the command line, we just run the Redis CLI, or we run this directly from Redis itself. It works either way. And we pass it the path to the Lua script. And this, of course, is hello, the same thing we have here. The eval command is what evaluates, what tells Redis to run the Lua script. Here is the example that would do the same work that we did already in PHP and with Redis. Just for readability's sake, I extracted these key names. What's up with that? It's bad practice to use hard-coded key names in Lua scripts. So you have to pass all the key names as parameters to the Lua script. So just for readability's sake, I extract all of them, define them here as variables, and then we just, from inside the Lua script, we just do this. Redis call. Can you guys see this? Okay, cool. Redis call, and then you define the command you want to call and the arguments it receives. You can see all the commands here, the three commands we do for every keyword. Here the other 4 commands. There are some missing here that I left out just because of no space. But it's this Lua script does the same work that we were doing in our PHP library. Here is now how we call that script. Also, through Redis CLI, define the eval keyword, define all the key names we want to pass as arguments to the function, and tweet. That's it. Really, really simple. And in only 1 network request to the server. So that's already much better, no? Yes. Okay, so, but someone would ask, okay, but how are we going to pass, how will Redis know what's in this Lua script? If we are issuing a network request, are we going to pass the Lua script every time? That creates a lot of network overhead, so how can we optimize that? Of course, there is a way for that. It wouldn't be Redis if you don't know. Redis always tries to optimize those stuff. So there is a way to preload the scripts in the server with the script load command, and then back to the script, and Redis returns a hash. It's our job to store that hash and make it connected in some way to our Lua script, and then we can run it. Instead of running with eval and the script, the entire script, we are running it with eval sha with the hash, and we just pass the hash here. The syntax is just a little bit different. In only this part here, we need to specify how many key names we are passing. There is no comma between the key names and the arguments, and that's it. That's in the documentation. It's not a big factor, so you wouldn't have to remember this specific thing from this talk. Pros and cons. The obvious pro is the speed. I don't even think there's a need to talk about it. That's the obvious thing. Then atomicity. This is more interesting. So while the Lua script is working, we can be sure that our data won't change. There will be no other clients that are going to change our data while we are working with it. And that is a good thing. Now, then logic moves out of your app layer. This can be a good thing and a bad thing depending on your point of view. Sometimes you want to hide some details, they're really not important stuff, and you don't want them in your app layer, in your, let's say, business logic, and you want to just start them in a Lua script. But many developers, and in many cases, would object because logic's place is in the app layer. It should be there, it should be in code. Lua scripts are a little bit trickier to maintain. They're not difficult, but they are a little bit trickier because you will always have to make sure that the server, the correct version of the Lua script is uploaded to the server, and that Redis will know to run it. And that of course, you will have the correct hash on the other side stored in wherever you're storing the hashes. And as I said, atomicity is a good thing, but that means that while your script is running, everything else is on hold. So if you're running some script that takes a long time, takes 2 seconds or more, no one else will be served. Everybody is on hold. How do you like this? I'm impressed. I'm really impressed by all this stuff. But we can do better. Redis modules. What they are? They are add-ons to Redis, written in C, but can be written in C++ or any other language that binds to C. Then when we load it, they're almost as fast as Redis core. We're going to define this better a little bit in a second. They let you expand Redis commands, even create your own data structures if what Redis already has is not enough. If you have specific needs, you can just create your own data structure with keys up to half a gig. They're currently, this is still not stable version, so they're currently in beta release candidate version 4.0. It's still not officially released. The Redis is currently at 3.2. But yeah, they're coming, and there are already many modules developed already that are out there being used by people. So the modules API reveals two main levels: the high level and the low level. The high level provides, it actually consists of only one function call. It provides access to the Redis core, not directly to the data, but to the Redis core. I'm going to explain that a little bit better with an image in just a minute. Low-level API gives you access to the data directly. Let's see what that means. Itamar Haber, which is a developer advocate for Redis in Redis Labs, did this measurement. So this is the time needed for summing 1 million solid test scores. Maybe not the best, not very similar to our case, because it doesn't include that many network requests. But these are the times he got. Using this is a local interface. So using a Python script, 1.2 seconds, Lua 1.25. I said, yeah, this is maybe not the perfect showcase for this, but this is the part that we want to see now. Using the high-level API modules, 1.05, using the low-level API, 0.1. So 10 times better results when they use the low-level API. Here is now also another slide from Itamar Haber that he was so kind to let me borrow. He also offered to help me with this talk. This is the representation of our relationship with Redis. Okay, here am I. I'm just kidding, that's not me. I mean, the slide was like that even before I started preparing this talk. It's from Itamar Hadar, as I said. Okay, so the user connects to the app that has a Redis client, instantiates a Redis client, that connects to the Redis server, that connects to the Redis core, that connects to the data. Okay, that's the usual way. That's what we do every time we send a get full request. So, for example, the core parses this, converts it into commands for the low level, and it sends back our data. Next, what do we have with modules? With the high-level API, the user connects to the app that instantiates the client that connects to Redis. It connects to Redis core, but we are going to just simplify that and say that it connects to the Redis module. The module, using the high-level API, connects to the core, sending commands to it, and the core accesses the data. And then all the way back. Core, module, client, app, user, happy user. With the low-level API, though, you can probably already imagine what's going on, no? Again, user, app, client connects to the module, which this time connects directly to the data. We can open up keys in the memory and word them where they are. We don't need to pass this data we don't need to take out the data from the storage, then take it to the core, then take it to the user, process there. No, we manipulate the data where it is. That's why we are getting those results that are 10 times faster than everything else. 10 times or more.
I think that the user is high at this level.
Yeah, she's really happy now. She has a smile. It's a really funny slide. I love that. Okay, so high-level API, I said, consists of this very important command, Redis module call, and with this function we can call any command that we know about in Redis. We also pass the context, which is an object that should be opaque to the developer. We don't need to know what's in there, but it contains, it's like internal Redis module string. It contains information about the client status, and some memory management. So then we send in this case, it's the increase command, and we send the arguments. Wait, I have this. And we send the arguments to the increase command. Then what's this? This is the format specifier. We just need to define what the type of this argument. In this case, it's Redis module string as received in the arguments of the module, and an alternative C string. Are there any C developers here? That is hard. That is hard. Okay, anatomy of a module. Really basic example. Let's just see what are the basic things we need to have in order to have a module. The definitions of the API is a header file, Redis module.h, provided in the Redis repo. And then this is the function that we have to have, called whenever the module is loaded, every module needs to have in it. We are first trying to register the module, or VRL. Then we are trying to register the command, or VRL. Our command, in this case, will be called tweak.process, that's I think some standard. And the module is called tweak.processor. Command line, function name. So in here, we're giving the module the function name, the function it needs to call in order to run the module. Here's the function. empty, but yeah, this is the same function we just defined here. Let's zoom it out. Yeah, this is the logic of the module that will process all the data and give us back what we want. Zoomed out, zoomed in, beautifully. Really basic, just, I'm really not a C developer. This is also not a stable release, so obviously I don't have anything in production that uses this. I'm just playing with modules. I'm super impressed by that. That's why I decided to maybe share my enthusiasm with you guys. So, really basic example. First, we would usually check if the number of received arguments is correct. Is the same one we are expecting. So in this case, let's say if it's not 5, we return this wrong-erity reply. Then we enable auto memory. What this does is it manages memory for us. If we forget to, I don't know, close some keys, release some replies, this is going to do it for us. So we don't need to do it. If we're C gods like him, we can do it ourselves. We can still manage our own memory, but I'm not at that level, so I would always use this one. But yeah, if you need to really manage memory on a more detailed or precise level, then you should be closing and releasing your own keys and memories to call replies or the other options there are. So then we define a reply pointer to a Redis module called reply, and we're using the command we saw in the previous slide, Redis module call, again increment, we send it one parameter, which is the key, and this function returns the reply, which we can send back to the client using this function. I don't know what happened. But it wasn't me. Using this function, reply with call reply.
That was Apple.
Where are you? What happened?
That was Apple.
Yeah, that was Apple, I guess. I don't know. I think it was the cage, actually, but okay. Reply with a call object. Now the low-level API, let's just show some simple examples. Again, we are enabling delta memory. We are defining the key, which will be a reply object. And here, we are opening the key, which returns a key pointer. We are defining if we want to read or write from it. Remember, now we are accessing the low level. We are accessing Redis data directly. So we probably need to be a little bit more precise. Do we want to read or write from that key? We specify the key name, which is passed in this argument, and then we can check, once we get this reply here, we can check what type of data structure it is. In this case, we're checking if that key exists. So we're just doing this check here, if Redis module key type is empty, and if it is, we're setting it to some value. How are we setting it? This is the command to do it. Redis module string set. And if you're interested to learn more about this stuff, you can just go through the documentation and see a nice specification of all of these commands and how can you use them. In the end, when we're done, if we are good developers, responsible developers, we can close the key. If not, we can just let the auto memory handle that for us. I forgot these errors all the time. Compiling. It's really simple. We on Linux, on OS X, we just pass the library name, so and gives us the process with .so. How we're loading that into Redis. We need to compile from source, by the way, get the unstable version. I'm assuming here we're in the same folder, okay? And then we just use the load module parameter, and we send the path to our compiled C module. And how do we run the command? We just call inside of Redis, okay, we're inside, tweak.process, that was the name of our command, and we pass the parameters to our command. And that's more or less it. That's how Redis modules work. I wouldn't say they're simple, I also wouldn't say they're complicated. I think it's simple to grasp the concept. But to me, the part that wasn't simple was dealing with C, although you can probably write in C++, then bind to compile to C. I really, if you want to know more about it, I think that idea. And I'll try to learn more for next year. Then things you didn't know about Redis, or things you probably didn't know about Redis if you want to be more specific. Big O notation. Anyone familiar with it? Good job. So for O1 command means that some function will be executed in constant. Sometimes I like the word in constant times, no matter the size of the argument, or let's say the size. Yeah, no matter the argument. In our case, that would be, for example, no matter how many keys we have in the Redis database, or no matter how big our hash is, O1 will always run in a constant time. So here are some commands that are running in O1 that are maybe not that obvious when you start to think about it. This for lpop. So for example, you can pop and push elements into lists. No matter how big the lists are, you can pop and push from the beginning or the end of the list in constant time. Exists, so you can see if a key exists in the database. No matter how big the database is, you will always have the same, have the response in the same constant time. Getting string keys, getting set, get big. So all of this from edge line, for example, this is returns the number of fields in a hash, no matter how big the hash is, or a number of some field in the length of some field in the cache, no matter how big the hash is, no matter how big the field itself is. This is interesting. This is the hyperlog command. Nowadays, it's used in IoT where we need to observe, to receive and process a lot of data, and we need to know the cardinality of that data. So the hyperlog data structure uses more or less 12 kilobytes. 12 kilobytes only. That's the maximum. No matter how much data we're sending to it. It only calculates the cardinality with the precision of 99 point something. So there is some small margin of error, but not really compensates for the small memory use. And with this command, we are adding to the hyperlog and getting the cardinality out of it in a constant time. Think about it. If you need to have that much data, getting the cardinality is usually not very simple and not a very cheap operation. With this data structure, you're getting it in constant time. Is member, so if some also, no matter the size of the set with S is member, you're going to know if certain element is a member of a set or not. Append to a string, no matter how big the string is, you get the idea. This is the list. If you ever need it, just remember that these commands can be maybe better, a smarter way to solve some problems. This is O1. So if you want to get a sub-range of some big string, you can use getRange or setRange to set it. It's ON depending on the length of the substring you're searching, but if it's a small string, you can get it in O1. Exploration and eviction. This is something that people often ask me about. For example, because when they compare Redis to Memcache, Redis expires keys in two ways: active and passive. active means that, okay, I set a key, I give it the time to live, and when I access it again, if it already expired, Redis deletes it. I only have 5 more minutes. Redis deletes that key. Sorry, that's the passive way. In the active way, Redis tests 20 random keys from the set of the keys that are set to expire, and tests if any of them expire. If they are expired, it deletes them. If more than 25% of those keys were expired and deleted, it goes back to step 1 and tries once again. And it does this 10 times per second. So think about this. In Memcache, all your expired keys stay in memory until you try to access them again. What if you never try to access them again? They fill up your memory, you're paying money for your server, for memory you're not using. With Redis, you don't have that problem. It does that for you. PubSub. Has anyone used the PubSub feature? So, it's pretty simple. We subscribe, for example, to the BG Web Summit channel. Another subscriber subscribes to 2 channels, to Web Summit and Sophia, and then a publisher publishes to some of the channels, and all the subscribers that are subscribed to that channel receive the message. Here is the sending of the message. Here we're just listing the subscribers. And because I only have 4 more minutes, I won't go into details, but it's simple, PubSub system. Here are some things we need to remember when we're using it. Once a client becomes a subscriber, it can only stay a subscriber. It cannot send other commands to Redis. If the application needs to query Redis, it will have to open a different client connection. You can subscribe to channels matching a pattern, and I hope this will save you a lot of debugging someday. Publishing on Redis has different databases. No? So if you publish on database 10, a subscriber on BB1 will hear that, will receive that message. Persistence. 2 options, and 3 options, and the combination of them. Point-in-time snapshot means that Redis will create an RDB file every X minutes, days, years. I think it's better to be minutes. It will just dump your data in it, and if you ever need to restart the server, if you have a problem, you need to restart the server, it will be very fast to recreate, to bring up the data just from this RDB file. Everything from the last snapshot up until the point the server crashes is lost. Okay, so it depends on you how important that data is. If it is very important, if you are a bank or something, you are going to use probably an append-only file where every command that changes the key space, so every write command practically, is written to the append-only lock. There is a command, of course, that will draw. Of course, it will draw. It also takes a lot of time, a lot more time to recreate the database from this file, but at least you are not losing any data. Obviously, that file will draw, so there is a command to optimize this file so it stores the least lines possible in order to get to the state of our key space. For example, if I issued 10 different commands, okay, set this to 5, now set this to 3, now set this to 2. After this optimization, the append-only log will just contain the last file, set this to 2, because we don't need these other 2 anymore. And of course, you can turn this completely off. The Geo API, very useful. It's just simple sorted sets, but it uses a geo hash, so you can do radius querying, and you can do distance. You can calculate distance in meters, kilometers. Okay, that's it. I don't really need to explain more details for this. We only have 1 more minute. And these are some Redis CLI commands that you sometimes might find useful. For example, the big keys, you can just list a number of keys that are probably eating up your memory. Monitor, you can see in real time which commands are being run on your server. Of course, this is not to be run always in production. You can scan keys by pattern, so never use the keys command, always use the scan command because it scans incrementally, it just traverses your key space, searching for keys that match a certain defined pattern. Statistics for your database, this refreshes every second, or you can define the interval. It just shows you how many clients, post clients, memory, which just gives you again general overview. You can, I didn't know this one before I was preparing this talk, by the way. I found it really nice to know. So you can just set and get from text files. In here, we're just setting the foo key to whatever is in the foo.txt file. Proof. And also the other way around, we can just pipe whatever we get from the key foo, we can just write that into the bar.txt file. And this is also an interesting one that might be useful, probably not for production, but for when you're working and you need to always run some commands. You can put them in a TXT file, for example, like this, and then you can just pipe that to Redis CLI, and that would work. I'm done now. Thank you. This is my speaker.